broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and thank you for joining the ZigBee Alliance webinar, ZigBee Remote Control 2.0, the updated standard for radio frequency-based remote controls. We have some great experts for you today, as listed on the next slide. And we will be giving you an introduction to various topics around remote controls, including an introduction by Case Links, the CEO of Green Peak Technologies, an explanation of ZigBee Remote Control 2.0 by Ted Grau of Comcast Cable, by Joseph Reddy of Texas Instruments, and Asham Hatanbaki of Universal Electronics. And we will also be conducting a question and answer period at the end. As you're listening to the presentations, feel free to submit your questions via the chat function, and we will try to get to as many as we can at the end of our presentation. As a reminder, this is an update to the presentation to a previous webinar about ZigBee Remote Control that is available at zigbee.org on the Learn More section of our website. And we will be recording this and make it available to you and your colleagues within a few days of this event. So without any further ado, let's go ahead and I'll turn it over to Case Links of Green Peak Technologies. Thank you.
Hello everyone, my name is Case Links. Thanks Ryan for the introduction. Besides being the CEO of Green Peak Technologies, I'm also the marketing chair for RF4CE, and we have been working the last 1.5 years on getting something beautiful together as ZigBee Remote Control 2.0 that I would like to kind of give some introduction to. Next slide, please. And in this introduction, I'm going to give some backgrounds on what is ZigBee RF4CE doing, and then later in the presentation you will hear more about some details that are introduced with what we call ZRC 2.0. So what is ZigBee? ZigBee is an open, low-power networking communication standard. Actually, it's the only one based on IEEE 802.15.4, which is an open worldwide standard for data communications in the 2.4 gigahertz, one frequency band, one worldwide frequency band. It's a standard that connects the widest range of low-power devices in networks, and by doing so, it helps consumers and businesses to control the world. Now, what is ZigBee RF4CE? ZigBee RF4CE specifically is a network layer on top of the IEEE 802.15.4 standard. It's a full member of the ZigBee family, and it is specifically targeted at human input devices. And what's important in human input devices in particular is very low latency. We all have the experience. You push a button once, nothing happens. You push the button a second time, and two things happen at the same time, which is highly annoying. So actually low latency is critical. But of course, low cost, robust against interference, etc., are other features that have been particularly addressed in this network layer. Now, on top of this network layer, there's also something like what is called ZRC 2.0, ZigBee Remote Control 2.0. And actually, that's a whole bunch of what we call an application profile, a whole set of commands, including how to connect, how to disconnect devices, assure security, assure proper functioning, and so forth. Everything that you can expect, or what I'm inclined to say that you almost take for granted, that is taken care of, and that is taken care of in the ZigBee Remote Control 2.0 profile. That runs on top of RF4CE, which runs on top of IEEE 802.15.4. So it standardizes remote controls. Different remote controls can be used for different pieces of equipment, and it creates a completely compatible environment. Next slide, please. So, what were the design criteria? Actually, in building a remote control, what we all know is that the remote control market is very much a universal market. Remote controls are available everywhere in the world. And remote controls in general are part of a family of devices that we call human input devices. So what we wanted to achieve is multi-vendor interoperability. We all hate multiple remote controls on the table, different remote controls working for different devices, and you always have the wrong device in your hands, and so forth. With this standardization of remote controls, that world is a world from the past. The world from the future is a remote control that can work with all devices, will be known for ease of use, simple pairing, simple commissioning. Remote controls for product vendors will be fairly straightforward. It will be one remote control that will be applicable worldwide. There are special design criteria included to make sure that Wi-Fi or Bluetooth interference can be, neglected. It has very low latency. I mentioned that already. So once you push a button, something happens. Security has been taken care of to make also the total device as low as cost as possible. The software footprint has been kept to a minimum size. So that are the design criteria, and what this leads to is in the next slide. If you look from the bottom to the top, this picture explains a little bit further how and what has been defined by ZigBee RF4CE. If you look in the picture, then you see at the bottom the MAC layer and the PHY layer. This MAC and PHY layer have fully been developed and standardized under the IEEE 802.15.4 working group. And it is, as I mentioned, using the 2.4 gigahertz worldwide standards. On top of that, there is a very thin and flexible networking layer that takes care of things like power saving, channel agility, about which a little bit more later, management, pairing, security, and the total system topology. It is interoperable. It takes care of secure communications, and it has several mechanisms for power saving and simple and intuitive pairing. Next slide, please. So ZigBee RF4CE, actually it was originally started by companies like Philips, Sony, and Samsung, and it has been broadly adopted by technology providers, product developers, and cable operators worldwide. Millions of ZigBee RF4CE devices are shipped every month. And also for the product builders, there's a wide variety of chip and technology providers, including software, available in the market. Next slide, please. So what is the ZigBee RF4CE experience? Probably the best frame of reference is where this is coming from an infrared remote control experience. The first and big difference is this is radio, so it goes through walls and it goes into cupboards and into furniture. It's important because if you have now a beautiful flatline television, you don't need a box sitting next to it. The set-top box or the device that controls the TV can be in the furniture, can be stashed away, can be out of sight. And I mean, for that reason, because it is radio and the range is very comparable to what we're all used to Wi-Fi environment. You can use, you can have the box located in even different rooms. There is no requirement for line of sight. You don't have to point and shoot the remote control to the set-top box or to a specific place on the screen of a TV. It's not sensitive for sunlight. It is very selective. You can, with one remote control one box that is paired with it, and about the pairing a little bit more later. It's a two-way communication protocol. So what happens is that also signals can be sent from the device back to the remote control, allowing for things like tactile feedback or triple tap entry. And not to be underestimated, but radio communications uses considerably less battery power, which means that battery life of remote control is significantly exceeding, even to the point of exceeding the life of the remote control itself. Next slide, please. So I mentioned the bidirectional capability, which gives a unique experience because it allows now to also send messages to the remote control, which can be things like, your favorite program is starting in any minute. It can send news highlights, sports results, stock information to the remote control. In particular, a feature that many people will like, that it is part of the standards, that you can essentially go to the TV or the set-top box, push a button, and have the remote control bleep or peep and say, "Here am I." Which I think it's a universal experience that parents have been looking for remote controls that their children just recently used and now nowhere can be found anymore, or children looking for the remote control that the parents kind of have been hiding. Anyhow, supporting new applications is also possible with the two-way capabilities like casual gaming or armchair payments. We know of this application being implemented in Japan. And that's a cool feature as well, because RF4CE is a member of the ZigBee family. The remote control can now also control other devices in the home, like lights, air conditioning, curtains, etc. So the remote control is not an isolated device anymore that is connected to a TV or a set-top box, but it is becoming a member of what we call the smart home, a complete, full environment. Next slide, please. So what's happening now is that the remote control is something to be considered also beyond the remote control. Actually, a remote control is an input device, and ZigBee RF4CE also supports all type of other devices that essentially can be looked at as remote controls in one or another way, like keyboards, like pointing devices, like an air mouse. So ZigBee and ZigBee RF4CE bring the experience of a very low latency device that is used for controlling other devices, actually in a much broader space than the remote control alone. And actually that's what we are talking about here. Next slide, please. I would like now to transfer the microphone to Ted Brown, and he will give some more detail about the ZigBee remote control to Europe.
Great, thank you, Kate. Great overview, and thanks for everybody who's joining around the world to listen to and learn about the introduction of the new ZigBee Remote Control 2.0 standard. My name is Ted Grau, and I run a team at Comcast Cable related to video devices and remote control technology. We go to the next slide, please. So overall, Zero C 2.0 is a really fantastic jump forward in the overall standardization of a global initiative on device control, remote controls, consumer electronics device controls. And I want everybody to understand that 2.0 is a natural progression from ZRC 1.1. It's not a lot of tear up of the underlying technologies. It's really an enhancement of the areas that were successful with ZRC 1.1 and now have been added on to make a more complete picture of technologies, a more complete package of technologies that can be further utilized by service operators around the world to provide a more completely standardized product into the market. Overall, the ZRC 2.0 standards, it's been 2 years since the introduction of ZRC 1.1, and as Case pointed out earlier, it's been about a 1.5-year process to start from where ZRC 1.1 left off and build to the standard. There's been a lot of involvement by the world's largest silicon CE remote control and service operators, and Case also had a great slide on slide 7 that showed a number of a lot of the companies that have been involved in both defining the standard, reviewing the standard, giving feedback, as well as deploying the technology. ZRC completes a full application all the way down to MAC-PHY layer standardization. So although this release of the standard didn't change anything at MAC-PHY, what I'm trying to say here is that the complete package in 2.0 is a definition of a completely standardized implementation from application all the way down to the metal. All major functions that are needed in service delivery of a remote control or device control technology is included in ZRC 2.0. Major functions required by the consumer electronics industries around the world. A lot of retail use cases are going to be enabled by the standard, and there's been a particular set of activities focused on making sure that there's interoperability between vendors, between silicon, between service operators potentially on these devices and at all different levels of the stack. And there's been a lot of activity on test plan and test house work is going on to prepare for the potential for devices to be certified in the near future. Let's go to the next slide, please. Right, so again, ZRC completes the process begun by ZRC 1.1. ZRC 1.1 was very successful in its own right, but it was never intended to be a sort of soup to nuts complete package of standardization. ZRC 1.1 was fantastic in that it standardized the lower infrastructure layers, the MAC-PHY and network elements around providing a structure for command and control for device control in point-to-point usage of 15.4 radio technology within the ZigBee standard. Where 2.0 does, what 2.0 does, and why we believe 2.0 will be successful, is that it really picks up from that work and expands it to hit all the areas that really were left open to interpretation or open to additional proprietary work under 1.1. So in the last couple of years, 1.1 has seen an amazing amount of adoption by major service operators in both North America and Europe, and it's beginning to see traction in both South America and Asia. And further to that, the thing that's been particularly impressive is that it's not just been in one particular segment, but it's been in satellite communications, satellite operators, terrestrial operators, cable operators, over-the-top providers of video and other services. 95% of that new business adoption by service operators has been in the last 3 years. And overall, the ZigBee Alliance believes that this remains the lowest cost and lowest power protocol for the purpose of command and control usages around the home and business-to-business environments. An ultra-high reliability of command and control and very, very high quality of service of individual packet reception and transmission, even in very high-noise environments. And Case touched on some of those points really well in his presentation. ZigBee 1.1 provided all the major building blocks for CE device control, and it's a great framework but service operators found that there were some gaps that needed to be filled, and that's what 2.0 has really been focused on providing. Every operator found that they needed some customization, and so as customization occurred over the last 2 to 3 years, we found that devices wouldn't be fully interoperable from operator to operator, and equipment suppliers filled in those application gaps with their specific activities. In the U.S. cable organizations and cable labs, there was a specific effort that was called MSO Profile back in 2012, and that did attempt to put in place some level of standardization for a portion of those application functions that were not defined in 1.1. But 2.0 really kind of takes that work and extends it quite dramatically to be a complete package. So let's go to the next slide, please. In terms of content and the subject matter experts that are going to follow me are going to get much more in depth on these details, but to just provide an overall picture, ZigBee Remote Control 2.0 includes a simplified RF binding and pairing option, activities and methods, group binding and pairing, so from one to many, many to one, framework for transferring both IR control information, both databases and individual commands across from one device to another device, and other use case specific metadata transfers from the device to the control and back and forth. And also that framework extends to transferring binary objects or binary large objects, such as firmware enhancements and firmware upgrades over the air. The Find My Remote feature was touched on by Case as well, and you'll hear a lot more about that in the next couple of slides following my presentation. And I wanted to emphasize that there was a specific focus in ZRC 2.0 on the low power implementation of the Find My Remote feature, because there have been a lot of custom and proprietary implementations out there in the market that literally relied on constant communication and really worked against the low power goals of ZigBee and of the standardization. The firmware update triggering methods are included, a device bridging framework. So I do want to emphasize that ZRC 2.0 is not a mesh network standard. ZigBee PRO is a mesh network standard. What is included in ZRC 2.0 is the concept that a device within the home ZigBee network can act as a bridge and take information coming from a point-to-point communication on ZRC 2.0 and bridge that traffic onto the mesh network in a more easy and readily available format. HID command bank is included, encapsulated into the ZRC 2.0 standard for use for pointers and keyboard style device control. And there's been a big focus on enhancing the security for making sure that packets can't be sniffed or information compromised. And let's go to the next slide. So I'll wrap up by just talking about now that the ZRC 2.0 standard has been released and we'll be seeing some adoption. The next steps here are to focus on not just the preparedness for interoperability, but actually to, at the alliance level, at the standards level, see that the work completes into specific programs and products and service operator deployments that achieve full interoperability and achieve a ZigBee certification. We do expect that there are some service operator deployments that will happen in the first half of 2015. ZRC 2.0 is foundational, we believe, for there to be a real retail market for RF remote control and device control technology. The retail market effectively gets enabled by the fact that all these application level features and functions can be implemented in the same way and be interoperable from one service operator, one consumer electronics company to another. And we also see ZRC 2.0 as a platform for innovation. There's a lot of frameworks, and you saw that from the previous slide, and they're in place for a number of data transfer use cases. And we believe that as the larger market adopts ZRC 2.0, we'll see a lot of interesting new features and function combinations come out from different developer communities and consumer electronics companies around the world. So that wraps up my part, and we'll go to the next slide. And I want to introduce everybody to Joseph Reddy, one of the main systems architects at Texas Instruments in this division of TI, and also a main contributor and author of the ZRC 2.0 standard. Thanks, Joseph.
Thank you, Ted. So I will spend a little bit of time getting into a little bit more technical detail about some of the features that Ted and Kate talked about. So the first thing that we did in ZRC2 was to have an enhanced binding mechanism. As you all know, so the binding is the process by which the user pairs the remote control with the equipment that they are binding it with. And this is very important because it's obviously the first step that the user actually does when they use the remote. So it's important that it be very simple and very robust and foolproof and all that. So ZRC1 already has a very simple what's called a push button scheme where the user presses the button on the remote and also presses the button on the target side, which can be a TV or set-top box. And that results in a very simplified pairing process. So one of the things we wanted to do with ZRC2 was to further simplify it and simplify it for the user, and to make sure that the user only has to do actions only on the controller side and not necessarily on the target side. So that's what ZRC2 enables, what we call the single-sided interactive pairing. So the advantage of this is essentially that the user only has to interact with the remote control and not the box. And it also adds an exclusive user validation to confirm the binding. One of the key features with ZRC2 is that it's fully backward compatible with ZRC1. So a ZRC2 device, a controller can pair with a ZRC1 target and vice versa. So there is no, from a user point of view, it's a very seamless evolution, and it's not really, not that they have to solve anything. In addition to the interactive binding, there is also a proxy binding feature. And what that means is it allows the out-of-band setup of the pairing entry. So, for example, if you want to use other technologies like NFC as an example, where you want to use that to pair the two devices, you cannot do that. You also have the multi-setup box environment where a home may have a main server setup box and then a multiple client setup box. So in this case, the user would only pair with one of the boxes, and that pairing is then propagated to all the client boxes, and the user doesn't have to manually pair the remote with each of the boxes. So overall, a push to simplify the actions on the user. Next slide, please. So the way it works is, so the user is trying to pair, and he has multiple ZRC devices in his home. He also has ZRC devices in his neighbor's home or in a room next to them. And one of the things with RF propagation is it's omnidirectional, like IR. So the remote can see all these devices, and the challenge is to find out which is the device that you want that to pair with. So the user essentially presses the button here, and what that causes is what we call the device discovery feature of RF4CE, where the controller sends out a discovery packet, and in response to that, it receives discovery responses from all the devices that are in the neighborhood, which can be devices in the consumer's home, but also devices in the neighbor's home. Next, please. And again, next. So once the controller gets all these responses, what it does is it actually ranks them according to some algorithm. And there's a few different ways it can do it. One of the things it does is, okay, this target already paired with the remote, as an example. So targets that are already paired would not be considered high in the ranking, as an example. It can use signal strength. It can use profile IDs and manufacturer IDs. There's a lot of information that is exchanged in this request response packet that enables the controller to make intelligent decision on who it should pair with. And once it does that, it sends out the next packet, which is essentially a pair request with the intended target. At this point, it's still a tentative pairing because even though the controller has made an intelligent decision, it's not 100% foolproof. So what we do is once the tentative pairing happens, and then there is some process of configuring of the device attributes where both sides exchange this information. The final step is the user validation, where the box actually displays a code on the display, which is usually connected to a TV or it could be some other means of display. display as well. And the user has to validate that pin code by pressing it on the remote. And when he does that, that actually validates the binding and confirms that this is actually the right equipment that he wants to pair. If that does not happen, then the controller automatically goes to the next box or the next target in its list and it tries to do the same thing with that one, all the way until it actually validates to the right device. So this way, the controller can pair with the right target. The user doesn't have to get up from the couch literally to actually do this whole operation, and do it just by working with the controller. And we also have a foolproof way, which is one of the main requirements, is that the user has to exclusively validate at the end and say, okay, this is the right device that I want to pair. So we are able to achieve all of that in the ZRP2 enhanced binding mechanism. And at the same time, the way the scheme is written, it will also work seamlessly with the ZRP1 device using the ZRP1 push button scheme as well. So you get all the benefits of ZRP2 while also getting the backwards compatibility of ZRP1. So this is a binding process and one of the main features of ZRP2. So next, I will talk a little bit about the home bridging aspect of ZRP2. As we mentioned, ZigBee has a ZigBee PRO standard as well, which is the mesh networking standard, and it's widely deployed today in a range of control applications like lighting, security, energy management, and RF4CE as well is also widely deployed in the context of remote control and setup of and satellite and other equipment. So it's now a natural thing to do to see, okay, how can we leverage the fact that these are two technologies that are using the same radio and the same magnifier essentially, and make sure that see if we can enable the RF4CE devices to control the ZigBee home network. And since RF4CE is essentially a control network and the TV or display, we have a very big display, it's natural that you may want to use the remote and the setup of TV as a user interface for the command and control of the home networking device. There's a lot of different things you can do, which is just one example of what you can do if you can bridge the network. So that's one of the features that we provided in the ZRP2, where the RF4CE device can actually talk to ZigBee devices that are in the same network. So in the next slide, so this is a very rough picture of the overall system of how it would work. So you essentially have a ZigBee network, or you can have more than one ZigBee network in your home. For example, you see lighting devices may form their network. The electric meter, for example, has its network and so on. And then the RF4CE, there are the two devices. There is a gateway device, which would typically reside in like a set-top box or a device that has a display connected to it. And this device would have the capability of joining both networks, both the RF4CE network as well as the ZigBee network. And it acts as a gateway to bridge and translate and forward messages between these two networks. So what we've done in ZRP2 is that on the controller, we added some new command message payload that extend all the ZRP2 home automation commands. So things like the security system, lighting control commands, all these commands that were defined for the ZigBee PRO network, we make simplified versions of it that we can send over the RF4CE network. And the RF4CE controller sends these messages to the set-top box, and then the set-top box has the intelligence to convert these messages into ZigBee home automation, corresponding ZigBee home automation messages, and then forward it to the right home automation device. So essentially what this means is from your remote control, you can turn on and off your lights in your home or do any other operation that you can actually do within the ZigBee network. And we think this really enhances the utility of the ZigBee network, the ZigBee PRO network itself, because one of the things with all these tiny sensor devices is that they don't have a good user interface. There's not a good way for the user to interact with them. And with the remote and the set-top box and the TV, we think this can provide a really nice window into your ZigBee network. Next slide, please. Security is obviously a very important piece of the whole picture here. I mean, it's a wireless standard. It's unidirectional, unlike IR. So the packets are, the overlay transmission can be received by someone outside your home. So it's important that security is considered from the beginning. So RF1 itself started off with a solid security scheme, which itself was based on the IEEE 802.15.4 security. So all packets have encryption, authentication, and also replay protection, so someone doesn't capture your packets and then replay them over and over again. And it uses AES 128 CCM standard algorithms, well-proven algorithms. So from a security point of view, ZRC2 adds a few enhancements. It keeps everything from ZRC1 the same, and it adds some enhancements on top of it. One of the things we added was the rekeying of the security material. So in ZRC1, the security material was set up once when they're using the initial binding process, and the same security material persisted for the whole lifetime of that link that's pairing here. And typically remote control, the actual amount of data that you send is very low, so this is not a big issue. But still, we felt that it's prudent to allow periodic rekeying of the security material. So that's what we added a feature to essentially do new key generation based on the security. So it really, it's an extra layer of security on top of what's already there. We also added an option to have vendor-specific secrets included in the key generation process. And again, this is a way for vendors to differentiate or operators to provide extra security for their customers. And we just use the proven and standard algorithms. So we continue to use AES 128 CCM for all the same security operations. For hashing, we use the AES CMAC hash algorithm, which is also a proved algorithm. So all in all, I think the RC2 keeps the security scheme in the RC1 and then adds a few more features on top of it that provides some extra benefits to the operators and the users. So with that, next slide, please. So I'll turn it over to Arsham Hatameki. He will talk a little bit about some of the other technical features in the RC2. Arsham?
Thank you, Joseph. So before I guess we get into the technical description of the implementation, it's good to look at the intent and the goals of the design, then everything else will make sense. Next slide, please. So you're looking at a snippet of our results from an ethnographic study back in spring of 2013. In simple terms, watching TV or interacting with the devices in the home as a whole is supposed to be a pleasant experience. Devices are supposed to be smart. You're supposed to be able to control everything. They're supposed to know what you mean when you're controlling them. But as you can see, that's definitely not something that the market as a whole has been able to achieve, at least in the form of a mainstream solution. There are people that are not aware that a universal controller can actually control all their AV equipment. There are people that do know the feature exists, but just don't go through the hassle of configuring everything. And to be fair, they really shouldn't have. And that's what we try to address with the next set of features that we'll get into. If you go into the next slide, we can take a look at the three design goals, three major topics, and those will then be broken down into specifics on how they're achieved. So basically, ZigBee Remote Control 2.0 is expected to provide the underlying foundation that you'll need to have a plug-and-play experience. Basically, like plug in the devices together, set up the wiring, however it may be, and then pick up the remote control, the control interface, whatever it is, whether it's in the form of a traditional remote control or it's actually a second screen device with virtual keys and so forth. And you should just start controlling it. There shouldn't be any manual, harsh process going through manual, code, all of that should be taken care of. Vendor applications, and so you should account for vendor applications running inside set-top boxes, TVs, or other devices that are able to intelligently discover connected devices. Now, this is outside of the ZigBee domain, so they can do the discovery, out-of-band discovery through other means, such as HDMI, for example. That's one of the common connections between these devices. And the discovery and automatic selection of the codes then should be able to automatically translate into a configuration for the controlling. So we have to consider this separation in the modes and how everything happens. Now, this is the out-of-the-box experience, but there's also this concept of on-the-fly change of activity. So you can imagine if your control interface is actually a second screen device, which is a smartphone that's able to directly communicate with your device, then at each point in time, you might want to present the user with a different set of commands, depending on the activity that they're going through right now. They're watching VDR, they're watching live TV, or they might even be in the process of interacting with their home automation device. So as we're trying to bring in control of more and more devices, you can imagine that there's going to be more activities, it's going to be dynamic, it needs to be dynamically configured. So all of these are already accounted for in the foundation that the RCP provides. Next slide, please. Looking at the AV equipment setup, so in basic terms, the set-top box is TV. You basically bring in either a new TV or you're setting up your new subscription service, and you power up the set-top box and connect it to the TV. There can be an application running inside the set-top box that automatically discovers the connected TV, either locally or through the cloud services. It has the control codes, control knowledge of that TV device. And steps number 1 and 2 will then give you the control codes, control intelligence required for a simple interface. Now, what DRC 2.0 then addresses, step number 3, which is the ability for the set-top box to, on the fly, reconfigure the remote control with the required functionalities that are necessary to basically power up the system, volume, watch TV, switch to different types of content. Next slide, please. If you look at, again, to reiterate, but more specifics here, the 3 layers of services that are provided here. The vendor application, as discussed, is responsible for out-of-band discovery of devices and maintaining a database of knowledge of how to communicate and control devices. The ZigBee Remote Control 2.0 profile provides action mapping server and client. So typically a server would probably run inside a TV or a set-top box, and the client would be running inside the remote control or the generic device profile, which is the underlying foundation that DRC 2.0 is built on, provides 2 layers of services, which action mapping server and client is actually notification server and client, as the name indicates, is responsible for dynamic reconfiguration of the remote control. So this configuration could be done either right after initial binding and validation, or it can be done throughout the lifetime of the product. You might go out and buy a new TV, or you might add additional devices to your system, and the system needs to reconfigure and heal itself as it moves forward. And in basic terms, a full server and client is the worker thread, if you will, that is responsible for enabling a low-power bidirectional communication between a sleepy node and a powered node. So basically the ability for the remote control to be able to sleep, but still pick up messages every once in a while from the set-top box and react. Next slide, please. So if you look at the out-of-the-box experience as an example, during the after the validation phase actually included during the validation phase that Joseph already talked to, there's a capabilities discovery step, which is necessary. Obviously, the two sides first need to get to know each other's capabilities. Based on the capabilities, then you can later on, after binding is successful, you can then start pushing mappable actions, the actions that triggers that you can actually reconfigure and what those configurations are and what commands you support on both sides. And you exchange that information, you generate a configuration based on the discovered information, and then you reconfigure the remote. If you notice, all the verbs are somewhat from the point of view of the state nodes, which is typically the remote control. So you push your mappable actions and you pull the action mappings. This is so that a remote control, which is resource constraints and processing, has resource and processing constraints more so than a set-top box of a TV, can be in charge of the communication. This way you can make sure that everything is transferred properly and nothing is lost along the way, there are no conflicts over there. So it's a very simple, clean process. Next slide, please. This is basically diving deeper into the configuration procedure. If you look at step number 1, where the version and capabilities are exchanged, you'll notice that the exchange happens in both ways. So both sides will get to know each other a little bit better. Then the action banks are discovered. Action banks are groupings of capabilities, commands that one side can generate or the other side can receive. So it's both as far as the X and RX for a capability. And then you can dive a little bit deeper inside each group and look at within a set of capabilities which specific actions do you support within the bank. So after these steps are done, basically the two sides have a good idea of general capabilities of the other side. Next slide, please. Now, the whole process of exchanging banks, as I said, that's dependent on the initial capabilities exchange. You have a simple flag. You can say that you want to get informed about the capabilities of the other side. If this flag is set, then the action bank exchange will occur. Now, there are a couple of other procedures that are not included in here, but are obviously needed. Different database vendors can have different formats. The ZigBee Remote Control standard also includes a very simple infrared format for a database, but also allows the flexibility for more specialized databases. If this flag is, for example, set, then you will have a procedure to discover the types of databases that the two sides support. And the same is also true for home automation. If home automation is supported on both sides, then you will basically go through the home automation supported announcement procedure, which will then expose the capabilities for this set of functionality. As you can see, everything is kept very flexible, and the whole negotiation is fairly dynamic, so that based on capabilities, everything will automatically happen. And this is the true meaning of the plug-and-play experience. Now, last is, even though two sides might support certain functionality, they might not support remapping those functionalities. So you can say you allow action mapping. You have action mapping client and action mapping server, so that means basically you allow to be configured, and you have the ability to configure from the two sides. And if both are true, then next steps will happen. Next slide, please. Next slide, please. Okay. So during the action mapping procedure, This typically, the verbs are from the client point of view to the server. First step, you push the mappable actions. These are all sets of attributes. Now, mappable actions are those triggers, those events, if you will, that will allow the target to remap to different functions. You can say things as simple as press of a key, or something as sophisticated as on hand proximity, do X or Y. So you can really configure how the remote really becomes an extension of the UI in the hands of the user. So you push the attributes that can be reconfigured. You allow the target already knows all the capabilities, all the actions and action banks that you support. It can reconfigure and generate a configuration and mapping table for you, and then you start pulling the mapped actions. If it fits in one path, you'll do it in one path. If not, you can do them in chunks until it's all done. Next slide, please. Now, the attributes, it's what you would expect as necessary. Each attribute includes device type, bank, and code. Bank and code we already talked about, so it's basically which group and which specific action within the group of actions. But device type is interesting because it actually allows the set-top box to reconfigure how a remote control would talk to a TV. This is pretty interesting if there are intelligent applications running inside the set-top box that are able to discover the capabilities of the TV out of band, through HDMI, through IP, through other means, then they can actually remap and pass on the intelligence to the remote control. And the user doesn't really need to do anything in that sense. Now, the action mappings and how you would map each action, the attributes, and it looks as the table that you see at the bottom. You can basically have either an infrared code, an RF code, or a combination of the two if you want to execute a series of reactions. For example, say, press the power button, for example, instead of 3 devices as following, device 1 power on through RF, device 2 power off through infrared, and so on and so forth. So it also allows, if you look at the last couple of flags, it also allows either a temporary mapping of a function, which is really useful for activity-driven user interfaces, so that you can remap functionality of the keys, stop screen keys, or actual hard button keys on the fly, depending on what the user is doing, or you can permanently remap the functionality in the remote so that it always does the same thing. And again, even if you do a permanent mapping, that doesn't mean you have no way of later on changing. That just means the remote doesn't have to keep on asking the target what to do on this key every time. It will continue doing what it was configured to until it is programmed later. Next slide, please. And again, the other underlying foundation was the ability for the set-top box or the TV, basically powered nodes, to be able to notify the sleepy node, which is the remote control or the second screen device. And this is done through client notifications. And there are kind of 2 types of action mapping notifications, negotiation notifications that really can be used. One is very general statements. So you basically request complete renegotiation of all mappable actions, or you can actually decide you want to only remap a subset of the functionality, and you basically notify the client to update the configuration, the mapping for that small subset. This obviously reduces the latency and reduces the power consumption through the process. And we kind of put in the flexibility to account for both. Next slide, please. And with that, I'd like to turn it back to Ryan.
Thanks, Asham. Thanks to everyone. We only have a few minutes for questions, but we did have a few submitted via the chat function. If even as we're talking, if you want to submit your other questions via chat, we will. If we are unable to address them live in this webinar, we will do our best to follow up with you directly. Ted Rao, you mentioned some retail use cases. Wondering if you could elaborate a little bit on that and how the remote control would be affected directly or enable some of those use cases.
Sure. So there's been a very robust retail market for a very long period of time, 15, 20 years in IR remote control technology. And there's been a very robust aftermarket in different consumer electronics device add-ons that you can get for your home entertainment system, television control, professional install control, home theater devices. What ZRC 2.0 is doing is it's allowing a complete standardization of all those extra features and functions that have not been standardized before in the RF domain. That once there is adoption by consumer electronics companies and service operators that we expect will happen very, very shortly in the same way that it has happened in under ZRC 1.1, that sets the groundwork for there to be an environment where companies will invest in bringing products like that to the retail space, to the Walmarts and Targets of the world.
Thanks, Ted. Case links, one of the big efforts in ZigBee Remote Control 2.0 was to create ZigBee home automation. I think that it might be difficult for people to imagine sometimes controlling the rest of their home via their remote controls, is controlling their provision or AV equipment. I'm wondering if you could just describe a scenario or two where you think this is common use by consumers for controlling the other features of their home.
Well, there are in the higher end audio and video equipment market segment already, many applications that you have a remote control in your hand, and with that remote control in your hand, what you kind of would normally use to control your TV, the channels and the volume. With that remote control, you also can open and close the curtains, put up and down the sunshades, turn on and turn off the lights. And that exists already today. And then I'm really talking about, high-end audio and video equipment suppliers. What we have done now is to make that just an open standard for remote controls, so that instead of this being high-end and closed systems, can be get fully into the open, can really benefit from the normal forces of competition in the market and become something standard for everyone. Now, having said that, I mentioned the lights, I mentioned the curtains and the sunshades. I can add the heating or the air conditioner, but essentially the sky is the limit. From a standardization perspective, there are no limits as such, because the remote control and in the way this standard is implemented, together with the target of the remote control, the set-top box, are fully part of the ZigBee home automation network. And any device that is part of that home automation network essentially has a two-way communication to the remote control. So the sky is the limit, and I've given a few examples as exist today in the higher end.
Thanks, Chase. We've got time for one or two more questions. Asham, I'm wondering if you could comment on this question. There was a question about the need to support both RF and IR controls in set-top boxes, for instance. I'm wondering if you could just comment on that. I mean, do you think that's going to be an ongoing long-term requirement for product developers, or how do you see that evolving over the long term?
Oh, that's a good question. I guess the only way that you do need a common ground, a uniform communication across devices. So if you look through the TVs and set-top boxes and audio receivers, you'll basically need to have a single unified way to control them all. As it stands today, infrared remains the one and only protocol that goes across devices. We have seen a little bit of divergence amongst different categories of devices at the moment. That's not to say that's going to continue forever. Hopefully my kids won't have to experience the same kind of fragmentation. But as it stands, you'll have to kind of account for a 6 to 7 year life cycle. So whichever day that you draw the line and say, all right, now we have a uniform communication across all devices, it's going to take about 6 to 7 years for those devices to get out of the market. So for that period of time, you still need to support your users. Otherwise, for the sake of technology, you can't really foresee an already existing market, which is not to the benefit of anyone.
Ted Grau, I'm wondering if you could comment on that from your perspective at Comcast.
Sure. So it's certainly something that we've been looking at for a while, and in particular, what we see is that the RF link between the remote and the control of the user experience for pay television services is really a much superior one compared to the IR. Now, we know that IR is going to be around in the remote control for a long time because the remote control still is going to have to control multiple devices depending on what action the user is trying to accomplish at that particular moment. Change the volume on the television, power off the television, change the volume on the home theater system, et cetera, et cetera. But what we do see is that over time, as customers, subscribers to different service offerings get more used to the fact that there's an RF link, a wireless non-line of sight link between the remote and the actual control of their user experience, we do see that there's a potential in future years for IR to start to go away in that particular link. But again, I want to emphasize, we don't see the IR going away out of the remote control itself for quite some time.
Thanks, Ted, and thanks to everyone. We are actually past our time. We have a lot of other great questions that we would like to get to, and we will do our best to follow up with you via email. If we go to the next slide, I just want to remind everyone that we do have other data information available to you at zigbee.org, and on the next slide you'll see some links to a white paper and some more detailed information about the standard. And just a reminder, we will send everyone who registered via email a link to the presentation slide so you can look at this and share it. And we will be posting a recording of this soon. So again, thanks to all of our panelists for their, not just for today, but for all their hard work in developing the standard. And thanks to all of our attendees. We appreciate your attendance. Feel free to contact us via zigbee.org, and we will do our best to follow up with you. Thanks and have a great day.